line. Understanding the slope helps you, is probably one of the most important concepts about a line. It essentially is the idea of how much a line is leaning or its steepness. You know, when they talk about the grade of a road, we're talking about its slope. So it's a very important number, and it is essentially a ratio, so fraction. It's a fraction that compares the rate of change in the y value to the rate of change in the x value. So if our coordinate plane is composed of x values and y values that we put together to make points, and then we collect all those points, they line up, they form this line. So what we mean by rate of change is if I place 2 points on a line, so at this level, so this point is at this level, and this point is at this level. What is its height change? That's the rate of change in the y value. So I could draw that with this vertical line here. There's the rate of change. Let's write that. And by the way, I think it might help to use an abbreviation, which would be a symbol, which is delta y. So that represents the change in the y values. And so when I want to represent the change in the x values, I could represent that with delta x. Okay, so delta y here is this length. And so how do we do that mathematically? How do I calculate that value? So from this point to this point, that's the change in y. It would be represented by a subtraction problem, taking the higher value, y2, minus y1, and that's our rate of change in the y values. And then similarly, we do that for the x values. So between these 2 points, how much am I traveling horizontally? So I'll draw a line to represent that distance. And that is this is delta x, change in the x values. And we would calculate that by subtracting the 2 x coordinates, x2 and x1. Now slope is a ratio between those two quantities. So I'm showing that here. It's the change in y, which remember we're going to represent with the symbol delta y. And I keep saying delta. That's just a Greek symbol. It looks like a triangle. So I just say delta for short, and then delta x for the change in x values. And that gives us something that you might be more familiar with, a rise and a run ratio. So the rise amount is divided by the run amount, and that's the fraction that builds our slope. All right. Now, to calculate slope, you always need 2 points on the line. So I'm showing you these 2 points here, and we're going to calculate slope of a couple of graphs. So in order to do that, we need 2 points on the line. Now, in the practice that you'll be doing, you'll most often just see a line drawn, and you'll need to locate a couple of points. I've located a couple by looking for where the line is crossing lattice points. Remember, lattice points are where the underlaying grid lines, the lattice lines, where they meet. So this right here, so any place, this is an intersection point right there, that is a lattice point. So where does my line cross lattice points? Well, one of them is at 3, 4, and another one is at 3, -1. So you want to redraw this, and then we'll go through and practice using rise and run and this idea here, the ratio idea, to calculate the slope of the line. All right, so first I'm going to do it using rise over run. And so to do that, I have to trace a path. So if I start at the lower left point and I trace a path along the lattice lines to the other point, then I would be going, if I start here and go up, I'd be tracing this path. So all the way up to this point, and then I would stop, because at that point I've reached the height of that point, and so I'm going up, and then I go across to the right, and when I get to the point, and there's the path I've drawn. So here is my delta y. And my delta y is equal to the change. I'm going up, and then I count how many lattice segments I've gone up. So 1, 2, 3, 4, 5. So this is up 5. And then I've gone across, or that's my run. I've gone to the right. I want to specify the direction. I'll tell you why in a moment. So let's count how much I've got. My delta x is equal to, we're going right, and I'm going right, count 1, 2, 3, 4, 5, 6, right 6 units. So my rise is up 5. So let's rewrite this in slope is equal to rise divided by run, which is equal to my delta y over my delta x. Just want to keep you familiar with those terms. I won't write all of that every time. And I've gone up 5, writing the words, and right 6. Okay, so now we're going to translate that. What does that mean as terms of your slope number? Why have I included all the words? Well, it's because the words and the directions have meaning with respect to sign. Up is, if this direction of up is a positive direction. It has to do with the y-axis. When we go up the y-axis, we're going in a positive direction. When you go down the y-axis, down is a negative direction. And so since I'm going up, the change in y is a positive change, so it's positive 5. And similarly with the change in x, my x-axis, if I go to the right, I'm going to in a positive direction. If I go to the left, I'm going in a negative direction. So right 6 means positive 6. And so this is the slope of my line. All right, so that's a nice way to do it when you're dealing with an image. Okay, so we're going to do this several times, but I also want to introduce to you a formula that will help us get you slope. So remembering that delta x is, we can get it mathematically or algebraically by subtracting the x-coordinates, and so that change in x is given by x2 minus x1. And the change in y is given by y2 minus y1. The only thing to keep in mind with this formula is that the order does matter. If you're using the second coordinate, when you write this formula and you write y2, you want to make sure you're using x2 below it, not x1. You don't want to mix these up. y2 over x2, y1 over x1. So just keep that consistent. And so let's go ahead and calculate this. We can use our formula. So slope is equal to, let's write the formula. So is y2 minus y1. So you get used to it. You should write things a few times. x2 minus x1. So y2 over x2, y1 over x1. All right, so what is y2 and y1? Well, that depends on which one you want to be y2, which one you want to be the first point and which one you want to be the second point. So that's a matter of choice. Well, what if I labeled this, if I call this my first point, x1 and y1, and the second point, if I call that x2 and y2. So you see how I'm labeling using the coordinates, so that way I can plug these in really easily. All right, so I start with y2, which is negative 2. And I subtract from it y1, which comes from the first point, which is positive 1. So I write a 1. So I'm subtracting the y2 minus y1, denominator. x2 minus x1. So x2 is 1. Minus x1, which is negative 1. So I'm subtracting the two x-coordinates. Now I do notice a double negative here, so when we subtract a negative, that is the same thing as addition. So let me rewrite this. So this is negative 2 minus 1 divided by 1 plus 1. And then that simplifies to negative 3 divided by 2. Okay, so that is our slope of the line, how much it leans. Now the negative is because my line is falling to the right. We'll review that in a moment. But when we get a negative slope, I should see a line that is falling to the right. When I get a positive slope, the line is rising to the right. We call that increasing. This one is called a decreasing line. Okay. All right, so let's take a look at, so two different ways. You could draw a triangle and then do rise over run, or you could use the formula. And just for emphasis, why don't we go ahead and draw in a triangle for this picture, just so you can see how it plays out with this slope number. Okay, so I'm going to draw a triangle above, just because I have space. I wrote a bunch of stuff down here. I could draw a triangle below here. It's just a little crowded, that's all. So I'm going to draw a right triangle, so right there. Okay, and so my delta y, I have to draw, before I can determine my slope, I have to do a path. So am I going to go to the right and then down, or am I going to go up and to the left? You have to pick. All right, so what if I just go to the right and then down to connect these 2 points in a path? Then that means here's my run. The horizontal is always going to be delta x. So it's positive 1, 2, so it's positive 2. My rise is actually going down, so that's my delta y is equal to down 1, 2, 3. Again, you're counting the number of segments till you get to that point. So 1, 2, 3. So it's down 3, so it has to be a negative 3. And then, of course, you put delta y divided by delta x to get your slope number. That's negative 3 over 2. And so you can see that those are the same, using the graph or using the slope formula. Okay, so what happens with vertical and horizontal lines? So let's take a look at horizontal line. So to do slope, you need 2 points. Here's one. It's the point, it's on the y-axis. That is called a y-intercept. And I just have to put some other lattice point on here, so I can pick any one I want. I'll just pick that one. Okay, I can't draw a right triangle path. The path is horizontal. So if I go from the left point to the right point, I'm simply going to the right so many units. I'm not rising at all. So we'll do this in 2 ways. First, I'll do it in terms of my slope is equal to, let's do it visually. So delta y over delta x. Okay, so my delta x, I'm going to the right. Okay, so delta x is right 1, 2, 3. Remember, I just picked this point here. I could have picked a point, this point over here. So that's delta x. And what's delta y? Well, since I'm only going to the right and I'm not rising or going down, I'm not going up or down, my delta y is 0. And so this plays out to be 0 over 3. And when you have a fraction with 0 in the numerator, it reduces to 0. So my slope is 0. All right, so how does this look if we use the slope formula? So remember, we're doing y2 minus y1 divided by x2 minus x1. Okay, so this point right here, I'm going to need the ordered pair. So negative 1, 2, 3, negative 3, comma, and then the y-coordinate is negative 1, 2, 3, negative 3. Do you remember how to write the equation of this line? This is the line y equals negative 3. Notice the y-coordinate is always negative 3. Okay, so again, so let's just apply the coordinates. If I call this, so you have to pick, I'll call this one x1, x2, y2. Me silly. Let me change that. I'll call this the first point, x1, y1, and then the second point, I'll call it x2, y2. You never have a point that's 2 x coordinates. It's always an x and a y. Okay, so y2 is negative 3, so this is negative 3 minus y1. which is also -3. And then I have to do x2 minus x1. x2 is 0, and x1 is -3, and I'm going to subtract them, so 0 minus -3. See some double negatives, right? So this is -3 plus 3. Double negatives, always a positive. And here's another double negative, so this is 0 plus 3. And you can see this is 0 over 3, which we already saw before, is equal to 0. So our slope value is 0. All right, so now that's actually true for all horizontal lines. We'll always that because they will never have horizontal lines have no rise. So delta y will always be 0. Let's do it again here. So I have a vertical line. It goes through the point 2, 0. To do slope, we need a second point, so pick any point you want. I'll just pick this one. Okay. And let's write slope equals delta y over delta x. Okay, so what's that equal to in this picture? So you need a path. Well, we just have a vertical path between these 2 points. So if I start at the point that was given, 2, 0, and I go up, I'm going to go up 1, 2 units. So up 2 is +2. And since I only go up and I don't move right or left, my run or my change in x is 0. This is an undefined fraction. We cannot divide by 0, so we say undefined. So in this problem, our slope is undefined, and that is true for all vertical lines, because all vertical lines, the change in x will always be 0. There is never any right or left movement. You are only going up or down the line as you travel across it. All right, so just in summary, these are 4 lines that we've explored. We have our rising to the right line. We have our falling to the right line. We have our horizontal line. And we have our vertical line. Okay, so the slope of each one. This one, I don't know the slope number. The slope number will actually change, but what I can say about rising to the right lines is that they will always be a positive slope number. A line that is falling to the right will always have a negative value for its slope. So this is called increasing to the right, rising to the right, increasing, and this one is called decreasing. You know, so if you play on the stock market and you saw the stock chart doing this, not a good sign, folks. Stock price is dropping, so be careful with that one. Horizontal, so this is the horizontal line, the slope will always be 0. Right, so that's the number 0. And a vertical line, the slope will always be undefined. All right, it's time for more practice.